This is more than just about a new launch system. It's about a new commitment to our customers, to reliability, to quality, to rigor. And you'll see it across everything we're building, designing, operating, our processes, our team, our culture. And the journey here will be manifested in one thing: a successful flight, again and again and again.
Early Astra focus was on speed and getting to orbit, demonstrating orbital capability with our mass-producible rocket design as quickly as possible. And that's because with every launch, we learned and were able to iterate the vehicle. But now we've learned a lot, so it's time for us to consolidate those lessons and build them into a much more fundamentally reliable launch system.
When we talked to our customers in the market, they told us they needed this larger vehicle sooner. And that's what we've used as kind of our principle to accelerate this roadmap and pull this launch system forward.
The launch system is really our next step, not just in the evolution of the launch system, but also in the evolution of how we do product development at Astra. So it's really a significant shift, almost like an Astra 2.0 in terms of how we do design, how we do verification, and then eventually how we conduct our missions and launches with the vehicle that is generated out of that new process.
We look at our strategy for mission success in terms of 4 key components. During the design phase, having strong reliability controls, building in redundancy from day one. During qualification, making sure that we test as we fly, and we do a robust verification and validation plan before we ever launch for the first time. During build, having strong quality controls, supplier quality, quality in our factory, and acceptance testing that shows that every product that's going on a rocket for flight is ready for flight. And during operations, making sure that we're ready when we arrive at the launch site to conduct operations safely and successfully.
Folks pay a lot of attention to the rocket because it's the thing that flies to space. But in reality, the launch system is made up of 3 key systems: the rocket, the ground system, and mission control. And they all have to work as one in order to achieve a successful launch.
So all 3 things need to be concurrently engineered at all times and evolved at all times to be compatible with each other.
The end goal of Astra's mission control is to get to the point that there's just a flight director and a vehicle operator. And between the 2 of them, they have all of the tools they need in front of them to be able to successfully navigate a nominal launch campaign.
So it's the whole package of fewer personnel, higher automation, and the remote ability to do all this, which adds to the efficiency and effectiveness in our ability to go do this from anywhere in the world.
Ground infrastructure plays a big role in the reliability of the system. It improves mobility, it improves technician accessibility, it's designed with serviceability in the field, not needing specialized tools or equipment. The entire system is designed to be more robust and easier and simpler for everybody to work on, so that way we can turn it around a lot quicker and fly more often.
Rocket 4 leverages learnings from a previous orbital launch system in a new architecture that significantly increases its payload capacity and increases the overall reliability and manufacturability of the launch vehicle. Rocket 4 is a 2-stage vertically launched LOX kerosene rocket. The structure is built almost entirely from metal, with a focus on manufacturing techniques that enable cost-effective production at scale. Rocket 4 will stand 62 feet tall with a diameter of 72 inches and a gross liftoff mass of approximately 66,000 pounds. The first stage architecture remains largely the same. The propulsion system has moved from 5 battery pump-fed engines to 2 turbopump-fed engines, which are expected to provide a combined maximum sea-level liftoff thrust of 80,000 pounds. The biggest architectural update to Rocket 4 comes in the form of the upper stage, which is now a common dome, common diameter stage. This will reduce the amount of redundant structure and aligns production approaches between the 2 stages. The upper stage is powered by a turbopump-fed engine, which produces approximately 6,500 pounds of vacuum thrust. The full diameter fairing on Rocket 4 provides a major increase in usable payload volume while building on a flight-proven architecture for separation. This fairing is designed to fit 1 ESPA Grande payload, 2 ESPA-class payloads, or several CubeSats. Rocket 4 will have a maximum payload capacity of 600 kilograms to 500 kilometers mid-inclination over the course of the product lifecycle.
We continue to believe that small, dedicated, cost-effective launch is needed by the market and will be rewarded by our customers. And so fundamentally, we continue to invest in the idea of small launch, designed for, executed for, manufactured for, and delivered at scale.
There's a lot of discussion in the market around, launch cost, and that typically translates into dollars per kilogram. But in speaking with customers, there's a lot more to it, and there's more factors that they consider, including time to manifest, time to get to the desired orbit, and ultimately being in control. And so that's what we strive to deliver on with our customer experience. We're here to support you along that journey to make your mission successful.
Chris Kemp stood in front of us and gave us a challenge, gave Astra a challenge. Myself and others have taken that to heart, and we need to build a culture surrounded by expecting and delivering success right out the gate.